All right, thank you, Doug. So as you just said, my name is Jared Stroud.
I'm Dan Szafran, and shout out to our logo designer, Mr. Micah.
And today we're going to talk to you about golfing with dragons, or how we've gone about building secure environments for capture the flag events. As we go through the content today, just a quick agenda. We're going to go ahead and dive into exactly what is a capture the flag event, or a CTF, how we as a team went about threat modeling for our capture the flag event and what we identified as our primary concerns, and then move on into, now that we've assessed what our concerns are, what are the controls we're going to put in place to either eliminate or greatly reduce potential errors or security issues that may come up in these said events, and then also finish with some key lessons learned around some soft skills that kind of round this whole thing out. So you may have heard of CTFs, or capture the flag events, before. Fundamentally, these are competitions that are super prominent in the information security or cybersecurity field. They happen at these conferences such as DEF CON, Black Hat, ShmooCon, so on and so forth. And effectively, competitors come up to solve some kind of challenge. It could be something more on the digital forensics side, network forensics, reverse engineering, so on and so forth. And they do these events largely to kind of demonstrate technical skills for prizes, jobs, notoriety, so on and so forth. Of these types of events, there is a wide variety of categories that they can fall into. Most popular ones you're going to see is what they refer to as a Jeopardy style CTF. This is where you just get a board of challenges, and then you, the competitor, go forward and you download the challenge, solve whatever that may be, and you submit your answer for points. That answer is typically referred to as a flag, which is why you see the flag pointed over to the right here. From a DevOps standpoint, these are pretty much on the easier end to host, because effectively what you're doing is hosting files for your entire competition to have them have the competitors come and fetch them to run them. The other two competitions that we have listed here, the Attack, Defend, or King of the Hill style, require a little bit more work on the infrastructure side of the house, because you're setting up an environment that is meant to be attacked by your competitors. So you're introducing known vulnerabilities or maybe some custom vulnerable services for your competitors to come and hack. So that's a fun piece of this, because you want vulnerabilities where you want them and patches where you need them to prevent any kind of extraneous damage from happening and causing some chaos. So of these events, we created a little bit of a spin on a Jeopardy style event that we called Ghidra Golf. If you're not familiar, Ghidra is a reverse engineering tool released by the National Security Agency that a couple of years ago has been open sourced. There's a lot of really cool free training online about it. And one of the really neat things you can do with this tool is automate your reverse engineering process. This could be parsing out some type of malware's configuration, decoding or decrypting data, or otherwise accomplishing some type of task. Quite literally automating your reverse engineering process, applying DevOps to your reverse engineering skill set. What Ghidra Golf fundamentally is a way to take a competitor's Ghidra script, which is really just a Java or Python application that automates that process, and then execute it in an automated way. Now, to rephrase that slightly differently, we are taking arbitrary Python and Java applications from competitors and then running them on our machines. Yikes, right? Maybe everyone that's in an InfoSec role just goes, that sounds terrifying. How are you going to go about doing this to ensure that you don't have excessive code execution or malicious functionality happen? Well, with that, I'm going to let Dan take over about how we started with our threat modeling process to identify some of those risks.
Sure. So we identified three major areas of focus for our threats and risks to our competition. So the first one, as Jared was just talking about, the rogue competitor, someone who submits some script that does something bad to our infrastructure and takes something down for the rest of the competitors. Second is infrastructure availability. So something in our system, something in our environment, our DevOps platform falls apart. Our competitors can no longer access or properly submit or run. Their challenge scripts aren't getting run right, so things don't work. Or we have broken challenges. So we write these challenges. They are often built on some sort of bug or error in a program. So they're supposed to find like, oh, this is the path we would exploit to find this secret information, get the flag. If that doesn't work properly, our quality assurance wasn't quite as good as it needed to be. We need to be able to solve why isn't the challenge being solved correctly. So there are two main things we looked at on the rogue competitor side, which is one, what can they actually affect? What could they break to ruin the competition for other people? So for example, if they write a script and it interacts with it breaks out of the execution environment and somehow can remove the challenge binaries that's on the runner host, suddenly the scripts we have won't be able to run against the binary, and all of the challenge running will be broken. So how do we model that? What threats do we need to protect against? And then how do we scan the code itself to look for those things? So are there any tools we can put into our pipeline for running the scripts that will say, this is a flag, that this is a piece of code we don't want run. We're going to not run this script and prevent the competitor from breaking things. In terms of infrastructure availability, one of the things with CTFs is a lot of times they're run by volunteers. So you may not have a huge budget, or you might be working within your own policy as an organization. So you might have access to something like a cloud environment or a whole host of resources to throw at it. So you got to monitor your budget. You got to make sure you use what you have. And then you need to, at the same time, take that and make it available to the world. So we want our competitors to be able to access it from anywhere. During the competition, we had a competitor competing all the way from Poland while we were running the event in Washington, D.C. So we needed to make sure they were available. So from our end, what we had a NUC lying around, an Intel NUC lying around from a previous effort, a previous project. And we use those to host our infrastructure. We use Prometheus and Grafana to monitor that. And then we use Cloudflare tunnels to take our infrastructure on the NUC and host it to the whole world on any number of NAT networks that we're behind. Because we're running this at a conference center. Who knows what that networking setup is upstream? We want everyone to be able to access it. We don't need to work with them to punch through NATs and get public ports. We have this Cloudflare tunnel to expose everything to the internet. In resolving broken challenges, this really comes down to who's responsible. So you gotta find a hierarchy of who's responsible for which portion of the infrastructure, so we can triage and say, okay, this went wrong. Jared's responsible for making sure that the challenge runner is hosting running the binaries properly. Let's make sure Jared's on that and we can have him on call when something goes wrong with that. So after all, our service that we're providing here is the competition. So we have people taking the time out of their day, out of the time of their conference. They could be listening to talks, they could be doing all kinds of things. They're taking times to run and play with our challenges. So we want to make sure we're not wasting their time. So now we're going to talk about implementing the controls and what we did to reduce all of these risks of things going wrong in the competition.
So as Dan just talked about with our availability and monitoring our infrastructure, we want to make sure that if you're spending time with us at the conference, which is already on the weekend, you flew in, whatever the case may be, we want to make sure that it's time well spent and you're getting something out of that experience. So while not groundbreaking to anybody that's in this space, we leverage Prometheus and Grafana to monitor our infrastructure. But we had a lot of success in actually identifying a broken challenge and resolving it, which is why we wanted to include it in this slide deck. So for our Prometheus configuration, we were simply scraping metrics of CPU and memory utilization to watch as Ghidra was executing these users' scripts. Up until about that 8 o'clock time frame, a little bit towards the right there, everything was fairly normal. But then you see a huge spike for about 22 minutes there. What that ended up being, as our alerts were coming in on Discord, was because a challenge that we had deployed was a statically linked binary. So any of the additional libraries that are typically resolved at runtime were actually bundled in this executable. So it was around 30 megs. For context, all of our other challenges were well under a meg. So when Ghidra was parsing this huge file, and it started spiking CPU. And then when you had 10 to 20 to 30 competitors all attempting the same challenge, this caused what you see here in a substantial spike in CPU utilization. What we were able to do after we identified that that was the root cause issue was recompile the binary to make it dynamic, to redeploy, to ensure that competitors who have spent time reverse engineering haven't lost any of that time. They can still submit and solve the challenge and score points while not jeopardizing our infrastructure. So we wanted to kind of show how Prometheus and Grafana both worked in our favor with this regards. So then moving into different controls throughout our environment. Right, all the way to the left, we have the actual application that we are concerned about. That's taking this user submitted script and executing it. So with that, right, you might have some source code scanning that you can do to try to identify any kind of low hanging fruit. But as we deploy this in our Docker Swarm environment, now you have an additional layer to be concerned with of the container image itself, right? Are these images that we're building from, do they have vulnerabilities that are going to cause any kind of issues for us? And additionally, at runtime, say we miss something in our application scanning, is there any additional hardening that can be done to prevent a potential breakout or to at least eliminate the potential functionality that that container can have? Moving even further up the stack, you have the underlying Linux host, right, which is running Ubuntu 2004 in our case on these Intel NUCs. Doing some traditional vulnerability scanning and hardening techniques can further help your defense in depth procedure. And then finally, your network and firewall isolation. Largely in the case of CTFs, from our experience, as Dan said, it's a volunteer run events most of the time. You don't have control of whatever your upstream is at a conference, right? You might be lucky enough to get an Ethernet drop, and then that is your environment, right? Maybe you bring your own firewall. That's an additional thing you have to carry. In our case, we were leveraging, again, Cloudflare tunnels and host-based firewalls to manage some of these access issues. And we can talk a little bit more in depth about each one of these in some problems that we solve with traditional practices or how we address them. So starting with our application itself, right? Our Ghidra runner, as Dan was talking about, which is actually taking the script and executing it. We wanted to try to find some low-hanging fruit here, and this is really what we found that SAST scanning tools were very good at. We could leverage, in our case, we actually ended up leveraging a utility called Bandit. So this is OpenStack's vulnerability scanner for Python. It's an open source free tool. Bandit does a really good job at identifying areas that you may want to look into. But what we found with a lot of these tools, right, is that it lacks the context. So if you have, let's say, a CI/CD team, and then you are the application developer and you're handing it off, if they don't have the context of exactly how your application works or how it's running, well, there's going to be a little bit of information that gets lost there in the scan outputs. We're going to take a look at that in a second. Additionally, because we were concerned with competitors shipping Java or Python code that would have malicious intent, we actually leveraged YARA to build our own custom implementation of ad hoc scanning for potential one-liners to get access to our machine. If you're not familiar with YARA, YARA rules are very popular in the information security space, specifically around the defensive and malware analysis domain. It allows you to specify a series of bytes, strings, so on and so forth, that you can use to detect, hey, we believe that this is malware because the XYZ rules have been hit. So effectively, we're writing additionally our own rule scanning engine leveraging YARA. The nice thing about both of these utilities is there's numerous integration opportunities. So if you don't have that AWS environment, because again, a lot of these are volunteer run, you can do ad hoc scans. If you are leveraging GitHub, you can have git commit pre-hooks that are going to do the scanning before you even ship something to a repo. But if you do have a Jenkins, GitHub Actions, so on and so forth, it sets itself up very easily to be integrated into those pipelines. An example of this scan output we have here is from our Ghidra runner leveraging Bandit. So the top two arrows I want to draw attention to first. What you're seeing here is what Bandit identified as a medium with low confidence that, hey, you're doing some kind of HTTP request without a specific timeout. So by default, the Python requests library, they won't time out. The upstream server will, and then that's where your connection would die. But we didn't have that specifically in here when we were doing our testing. And it labeled this as a medium. Okay. Now, if we look at the middle here, this is the real big piece that I want to try to draw to everyone's attention, right? We have severity deemed low, and what we look in here is, hey, we have a sub process call, check for execution of untrusted input. Well, in the case of our application, this is where the user's arguments are being constructed to actually execute Ghidra. So if anything goes wrong in terms of a data sanitization or an application code scanning here, it's prime for code injection. So while you don't see the context here of how we're actually doing that said data sanitization, it's just not a low in our eyes, right? So these code scanning tools are really great for bringing attention of areas to look into, but the context is not captured. And that was a big takeaway from us early on as we started integrating this and then bringing in some individuals that were focused a little bit more on the hardening aspects. Additionally, I mentioned YARA and kind of integrating those rules. So here's a short example rule along with our GitHub link here at the bottom. Effectively, what this ends up looking like is a JSON-esque structure where you have a handful of strings in our case that we were looking for. It's not uncommon for, say, CTF events that are more focused on attack, defend, or king of the hill, of once you get limited access into an environment, that you execute what they would refer to as a one-liner to get additional code execution into an environment. This can be done in numerous ways. We played effectively a little bit of a whack-a-mole approach of common ways that CTF players get access to said environments, so that way we would flag on those keywords. If those words were flagged, the competitors were warned that, hey, we think you're doing something nefarious here. Let us know what the issue was in the event of a false positive. Obviously, there's situations where some of these words might be either in the user scripts legitimately, perhaps it's in a comment, so on and so forth. So we did have a communication path forward in the event a false positive occurred. And then moving up the stack, looking at the Docker image itself, right? We're leveraging some community capture the flag infrastructure referred to as CTFD. It's probably the most popular CTF platform out there that's open source. And it's pretty easy to grab a handful of these open source utilities and just spin up your own CTF, whether it's for internal training, so on and what have you. But the patching and updating of these, it all kind of depends on the community and their associated release cycle. So leveraging Trivy, an open source vulnerability scanner, we were actually able to scan our images and identify some pretty easy low-hanging fruit vulnerabilities that we could go forth and patch. But beyond just scanning, right, we want to really harden this runtime. And with that, we could leverage our Docker Compose file to drop specific capabilities to ensure that our processes can't execute certain commands or certain functionality, and then have only the functionality that it needs. We'll talk a little bit more about that in a second. Finally, one of the most useful things that we found is actually leveraging some of OWASP's top 10 guides on container auditing to remove that low-hanging fruit. So in the event someone does get code execution, we've really limited what the exposure could be for that rogue competitor aspect. Looking at our vulnerability scanning here, right, we see we have 188 vulnerabilities. That's not good, right? Can't be good. And if we look to the right, we see we have 15 critical, 57 high, so on and so forth. Well, the root cause of this was from an old Redis image that was still being used in our CTFD environments, right? If you look at the right above that red line, we see we have Redis:4. We were easily able, in our case, to bump this to the most recent version of Redis because it was just being used as a glorified key value store for tracking session cookies. That's not going to be everyone's experience, but understanding the services that you're going to be using from these open source repos and then getting the context on those vulnerabilities is super important for you to accept the risk on, hey, is this actually critical for my application? Or does this just happen to be an additional library that's shipped in this image that may not concern me? For our runtime hardening, as I mentioned before, dropping extraneous capabilities provided super useful for us. And if you're unfamiliar with capabilities in Docker containers. Effectively, this is privilege control for privileged processes. So if my container should never leverage the kill command or should never shroot, so on and so forth, we can stop that from happening by doing this capability drop. For those that are a little bit more familiar with kind of container runtime environments and hardening, there's additionally something called SecComp, Secure Computing, and it ships by default with Docker and a handful of other container runtimes as well, and has a series of sane defaults that quite literally deny specific syscalls from being made. We found that it was a little bit more of a whack-a-mole approach working with our challenge developers of what syscalls are we going to eliminate, so on and so forth. And we found that it was a little bit more easier to do the iterations through dropping capabilities and then adding only what we needed. Your mileage may vary, but it's important to know what those utilities are that you can use to harden said runtimes. Additionally, leveraging non-root users, so that way if you do happen to compromise the container, you don't immediately get access to everything in the container, was super critical for us. Having unique flag directories per challenge further let us limit the scope down to what would happen, say a given challenge was compromised, and then adding in read-only mounts to prevent challenge tampering. Again, rogue competitors, beyond just trying to sabotage our environment, we don't want them to sabotage a given challenge for another competitor that would ruin their good time. Now, with that, I'm going to go ahead and turn it back on over to Dan, who's going to talk a little bit more about implementing controls at the Linux layer and so on.
All right, so for the OS scanning and the verification that our controls were working, we utilize a couple different tools, one of which was LinPs, the Linux privilege escalation awesome script. Great name, great tool. It does a lot of checking for common privilege escalation techniques. It's pretty thorough in what it goes through. We use that both at the container level and at the host level to check for privilege escalation techniques in the event of code execution beyond the scope we intended. Another tool we utilize is OpenSCAP, which is the open source vulnerability scanner based on the security content automation policy, I believe. That is another tool we utilized for checking the host, just to check external access and other vulnerabilities. You can configure it with a bunch of different profiles depending on your needs, and give it an XML config to customize what you need. Here is an example of our run through LinPs. This is specifically in a container. It's checking a bunch of privilege escalation techniques within a container. You can see it's checking if there's breakouts, whether SecComp's enabled, etc. Like Jared said earlier, depending on the context you're running this in, you may not care if run ushare has a potential privilege escalation vulnerability, or you might. So you're going to have to take a look at your own use case, figure out if that's actually a concern, if it's exploitable in your environment, and if it's going to actually impact your uptime. And the main reason we utilized these tools was to see, okay, so we're dropping these capabilities. Did that actually do anything to improve whether or not our container is escapable? Did this control we implemented on the host, did it actually mitigate these potential threats? Good double check for your work being valuable. And the networking layer, we have the isolation of the code running, and we have zero trust implementation. So we utilize Cloudflare tunnels for access control, both to our platform for accessing challenges and to our infrastructure, so that we could enable remote support of the event. And we also took the step of isolating our container running the Ghidra scripts and the competitor scripts. We separated that from the CTFD instance, and we also separated that completely from the internet. So this is sort of our pipeline, a little bit of a visualization. We have on one NUC, on the right side, we have the NUC running CTFD and our queue, and the other side we have our runner, which is taking jobs from the queue and saying, all right, I need to take this script which has been uploaded, and I need to run it against this challenge. So we're going to do that, and then the output, we're going to send it back to CTFD. Did they get the right flag or not? CTFD will make that call, and then that will be the competitor getting the solve. The Ghidra script running host, we ran on a NUC with a Thunderbolt connection. We made an overlay network over the Thunderbolt connection to the other NUC, and then had no routes outbound towards the internet. So if a competitor was able to gain remote code execution somehow on our Ghidra runner box, they would not be able to call out to the internet anywhere to download any payload, staging, etc. They would be dead in the water there. So that was the step we took to isolate the network. And then all of the exposure we did to the internet of our for our management. So we had SSH exposed, and we had and CTFD exposed to our competitors. All of that was done through Cloudflare tunnels. And this was incredibly helpful because, like we said, we're behind probably a couple layers of NAT at the conference center. So we've got a piece of hardware running Cloudflare tunnels. And through Cloudflare tunnels, we were able to open up SSH and the web ports for our web application. We allowed the entire world to access the web application when the competition was live. Beforehand, we only allowed our admin to access it to upload challenges and stuff. And we also had SSH access through Cloudflare tunnels to our host. And that was also only for administrators. And all this is controlled, access controlled using OAuth through GitHub. So we had a GitHub group for our competition. We had all of our administrators in there. We added them to the group. We were able to make sure they had two-factor on their accounts to make sure nobody could just simply pop their accounts and then pop the rest of our competition. All of that was controlled through GitHub. We can then whitelist those users in the Cloudflare tunnels, and then only those users can access that particular service on the NUC. So we had SSH. We had an incident at dinner time. I was sitting at a restaurant and I needed to log into the box and check why somebody's, as Jared mentioned, somebody's script got flagged for one of our YARA rules. It was a comment, so I had to SSH into the container, SSH into the infrastructure, look into the container, find the script. All that was enabled from my hotspot, not on the same network as the NUC, from a restaurant down the road, because we had it through Cloudflare tunnels. And all of this is hitting Cloudflare, not our infrastructure. So if there's DDoS attack, Cloudflare handles that, and it doesn't stress our NUC out any more than it has to. Back to Jared.
Cool. So as we went through some of those technical controls, right, of what's enabled our success for Ghidra Golf and also Battle of the Bots as we come to these competitions, we kind of came out with some more soft skill side of the house that we learned early on that can resolve a lot of issues faster than not. And it really comes down to just clear communication and responsibilities, right? So it's really easy to scope creep on who owns what, right? Because if you own the application and you built the container and you deployed it, so on and so forth, it's easy to kind of get entrenched into, well, I'll just troubleshoot all of these things. We have found that what that ends up doing is putting one person in too many places at once. And then if there's multiple fires to fight, so to speak, it's really hard to resolve those situations. So identifying who's responsible for each layer and how you're going to go about actually executing your response plan, whatever that may be, is super critical. At the same time, about that response plan, having one and then understanding how you're going to communicate is super important. So again, these are largely volunteer run events. So you might have someone hit you up on Discord, maybe someone prefers Slack, another person's texting you. That just creates chaos in an already chaotic situation, especially at these loud events, right? Having a clear way of what you're going to do when an event is occurring, who's going to respond to it, and how you're going to communicate with everybody effectively, to include your competitors, is super important just in the effort of transparency if something wrong is going on. And then finally, even with all of these controls in place, right, having a plan for failure. During one of our events, we had a competitor get a little too close to one of our NUCs and accidentally kicked it, and that caused our NUC not to actually boot, right, could not identify the NVMe drive. However, we had planned for this and had a spare on hand, which we were able to swap out, spin back up with limited downtime, making sure that the competitors could get back to solving their challenges. So if any of this was interested into you and you want to learn more, we have a couple of websites you can check out, Ghidra.golf and battleofthebots.net. We already have all of our Ghidra Golf related configurations for you to go deploy your own, run it, so on and so forth. Check out the code. And we're working on open sourcing our Battle of the Bots content right now so others can run this. Thank you all so much for your time. We're happy to answer any questions and we really appreciate it.
Make sure to come see us at DEF CON this year.
Yeah.